director of the Lawrence Hall of Science. It's great to see people from near and far. Near would be hall staff and visitors from Chabot. Far would be teachers from all over the country who are working with FOSS, and all really looking forward to, with great excitement, Andrew Fraknoi. Those of us who listen to NPR will recognize his voice in a heartbeat. He's always providing interesting ideas for us to think about. And so I'm really looking forward to hearing from Andy, and we welcome him to the hall, and welcome, welcome.
All right. Well, thank you very much. So I'm Andy Fraknoi. I teach at Foothill College in the South Bay here near San Francisco, and I work with an organization called the Astronomical Society of the Pacific. And I just wanted to see who everybody was before we started. How many of you are teachers or part of the workshop for teachers that's going on now? That's all the people daring in the front. And how many of you are members of the public who came for this lecture? A few people. And how many of you are regular visitors to the hall who just needed to get a cool place to rest for a minute? There we go. Excellent. Okay, so as you heard, this is part of a program that the Lawrence Hall of Science puts on for teachers. And so I'm going to spend 1 minute talking to the teachers, and then we'll begin the general lecture and discussion. For those of you who are new to the idea of the solar system today, let me begin by just saying that we live in incredibly exciting times. For the first time in human history, we have, or are about to have, close-up images of almost all the worlds with which we share our family of planets, which is called the solar system, or the sun's system. Never before have we been able to see neighbor worlds in as much detail, with as much clarity, with as much up-close personalness as we're seeing today. And so I thought I would share with everyone here today some of the exciting results of our exploration of the solar system. Now, I'm a college teacher. I teach very reluctant non-science majors who have to take a science class to get out of the college. And so I'm always trying to think of ways of making my course more sexy, more exciting, more fun for the students. And when I teach my course on the planets, students are often overwhelmed by the number of places that an interplanetary tourist might visit as we study the planets. And so for review, I hit on this idea that I would make the students get together in groups and make a travel brochure. So imagine it's the far future, and in this distant time, planetary travel is not just possible, but relatively common, but not cheap. And there is a very wealthy young woman, we'll say her last name is Gates, who is planning a honeymoon tour. And she and her fiancé love astronomy, they love the planets, they're courageous, and they would like to go to the 10 sexiest, most dramatic tourist sites in the solar system. And the assignment for my students, and your students can do this too, this has been done from elementary school all the way up to college. The assignment is that they should form a travel agency, a boutique travel agency of the future, and they should come up with 10 really exciting sites. But the challenge is they're not the only agency bidding for the business of this very wealthy family. So they've got to make a presentation to convince the family and its representatives that their tour is the one to get. So what are you going to do? You're going to put together a travel brochure, you might have posters, you should come up with sexy tourist attractions, you should come up with activities for the honeymoon couple to do, but this should be family rated. And you should sell this tour to the couple and their representatives. And the students have a lot of fun doing this. Elementary school students may need some help with a list of possible sites. The older the students are, the more chance they've had to study the planets, the more you can leave them to their own devices to come up with a tour. If you don't have a lot of time, it can be 5 exciting sites. If you have a lot of time, it can be 10 or even more exciting sites. And the deal is, it can't be a whole world. So they can't say we're going to Mars because it's exciting. It's got to be a specific, visitable tourist site at each world. Some place that you can describe as a particular place on a world or above a world, not just the whole world. And as I say, students have a lot of fun with it. You can make it as elaborate as you want, but I'm going to give you my list of some of my favorite sites to do. So here is the right solar system. This is the one we live in. This is the planets in order of size. You can see it's a slightly old slide because Pluto, poor Pluto, is still listed as a world of consequence on this slide. But you can see that the Earth in the middle there is by no means the largest world or the most colorful world. It just happens to be our world. And we'll look at some, but not all of these worlds in the solar system. Behind them, you see the sun, our star, which dwarfs the planets. But it is an enormous hot ball of gas shining under its own power. That's what a star is, a giant ball of hot gas shining under its own power. So let me begin our tourist tour in perhaps the most unlikely place here. This is our sister planet, the planet Venus. We call it our sister planet because it's about the same size as the Earth, but it's very different in very profound ways. This is the best dramatic close-up picture of Venus ever taken. If you're underwhelmed, you've made a major scientific discovery. In fact, Venus is perpetually veiled by clouds. There hasn't been a clear day on Venus for over 2 billion years. And you can't see anything on the surface of Venus because the cloud level is so high, so thick, that there's no penetrating it with light. In fact, when we explore Venus, we have to do it with radar beams that can penetrate the clouds, bounce off the surface, and give us some idea of what's going on. Here is a radar image taken not quite at random, because I like this radar image a lot. On radar images, dark means smooth, light means rough. So this is a couple of 100 miles of terrain on the surface of Venus. And if you look carefully, you see Miss Piggy. Do you see Miss Piggy? Her snout in the middle, her 2 eyes, an ear, her flaxen hair surrounding it. Of course, it's not really Miss Piggy. It's just a landform that happens to resemble Miss Piggy. But I like it. You can see, for example, her ear and her 2 eyes are giant pancake volcanoes where slow, oozy lava has emerged and come and made a rounded plateau. Though that kind of slow, oozy lava is characteristic of the volcanic activity that we see on Venus. You see, the clouds on Venus have done interesting things. One of the things they've done is they've acted like a giant greenhouse, so that in fact, although sunlight can filter in to the environment of Venus, heat can't escape. And so the surface temperature on our sister planet is 900 degrees Fahrenheit. Hotter than the self-cleaning cycle of your home oven. Right? Not only that, that was at 900 degrees Fahrenheit, but the atmosphere is 95% carbon dioxide, the stuff we like to breathe out rather than in. So for many reasons, your first deep breath would be your last deep breath on Venus. But we do now have very good radar coverage of the surface of Venus. We've learned a lot about it. And so I want to show you this radar image, helped by a group of arrows. can you see a river on Venus? Can you see the arrows pointing out a small channel, a section of it? What we're seeing there is a lava channel. And you're only seeing a couple of 100 miles of it here, but we've now discovered that this lava channel flows on the surface of Venus for over 4,000 miles. Imagine a single river of lava. It's the same thickness for 4,000 miles, flowing for an enormous distance, completely connected, for more than 4,000 miles on the surface of this planet. We call this Baltis Valley, B-A-L-T-I-S. It's a lava tube, and here's a kind of artist's impression of what it might look like if you could see it. Probably molten lava. You can't have liquid water making rivers when the temperature is 900 degrees. At 900 degrees, water tends to evaporate. So this must be some kind of lava that's making this long single tube, this enormous, impressive river of lava. It's just a little longer than the longest channel on Earth. All right. So we're ready to move on, because this is a tourist tour, so if it's Tuesday, it must be Mars, we gotta move. So I have a postcard for every planet, but I won't show you all of them. This actually, I think, was a set of postcards from Berkeley in the 1980s. Someone in Berkeley made these postcards. This is my Mars postcard. Mars, indeed, is the red planet, and I want to show you a few things about Mars. So this is the best close-up picture of Mars from space, and you can see Mars really is reddish. The sand on Mars has some of the same chemical characteristics as rust on Earth. There is an atmosphere on Mars, but it's extremely thin. If you were to take a breath on Mars, if you were to land on Mars unprotected, without a spacesuit, the pressure would be so low that your blood would actually start to boil, which is uncomfortable, to say the least. The very thin atmosphere is, again, made mostly of carbon dioxide, but it's not a place where we can survive in any way without a spacesuit, whether it's breathing or the temperature or the pressure. Nevertheless, with a spacesuit, Mars will be quite a tourist attraction. And I'd like to submit to you that if there's one planet that your great-great-grandchildren might visit for fun, it will be Mars. Not only is it relatively nearby, but it's a terrific place in terms of geological attractions. So one of the most amazing things on Mars is this Great Canyon system. And I put the United States to scale there to impress you. So this canyon system, which is called Mariner Valley, named after the spacecraft that first observed it, is so wide, so long, that it would reach on Earth from Los Angeles to Washington, D.C. So next time someone from Arizona is getting obnoxious about their Grand Canyon, just mention Mariner Valley on Mars. It makes the Grand Canyon look like a ditch in comparison. It's really an incredible system. We're not sure where it comes from, but one theory, which I like a lot, is that Mars is a much smaller world than the Earth. It had much less internal energy. So you know perhaps that the Earth has plates on it. The continents are sitting on these great plates which float on a more liquid layer underneath. And the plates have broken up, have moved apart. So we have the great plate that's North America, the great plate that's Europe and Asia, and so on. Well, we have on Mars the same attempt here. Mars tried to get plate tectonics going by ripping itself apart in this one region. And then Mars said, you know, man, that's too much work. I'm just a little planet. I don't need all this hassle. I'm just going to stop. And so plates never formed on Mars, but this is the one rip the one volcanic kind of place where the process began and then Mars gave up. We don't know if that's right, but I like it as a theory. So this is the Mariner Valley on Mars. It's really quite something. The walls of the cliffs are sometimes as much as 3 miles high. The cliff itself, the canyon, is 50 miles wide in many places. The deepest it's ever get, in the deepest place, is 6 miles deep. Compare that to the Grand Canyon, which is only 1 mile deep. And this is as long as the United States is wide. Surely, even if you don't descend into the canyon, you're going to want to fly over it if you're a tourist. Here is one small part of that canyon, and you can see, if you look at the upper part, some landslides where material has slid down the face of the cliffs. So probably the canyon has made itself bigger over the years with activity on the surface of Mars. But Mariner Valley is one of my favorite places. But now, I gotta show you my top tourist site. This is the one that I recommend. For all tourists, whether they're on a honeymoon or not, this is gonna be the attraction, and that's the largest volcano in the solar system. So ladies and gentlemen, may I present Mount Olympus. What was Mount Olympus in mythology? Anybody remember? The where? Sir? Yeah?
The mountain of God.
The mountain of the gods, where the gods lived. And just to make sure that everyone was impressed, it was supposed to be the tallest mountain possible, so the gods could feel superior in Greek mythology. Well, this is the tallest mountain in the solar system. It's 3 times the height of Mount Everest. And how big is it? Well, that's the trouble with these slides. Everything on the slide is as big as the screen, right? So you have no way of knowing how big it is, so I've given you a scale there. There, with apologies to John McCain, is the state of Arizona. Okay? So here it is, a mountain 3 times the height of Mount Everest and bigger in its base than the entire state of Arizona. To my mind, this is going to define macho in years to come. You will not be a macho outdoorsman or outdoorswoman until you've climbed Mount Olympus all the way to the top. And since the air is thinner than the air at 10,000 feet on Earth, you better bring appropriate equipment if you're going to be making that climb. It's quite a mountain. 15 miles high. Bigger than the entire state of Arizona at its base. So that's certainly one tourist site that everybody's going to want to visit. But I now want to move us beyond the inner solar system and take us to the outer realms. How we do? Perfect. This is the planet Jupiter, the largest of the planets. And I love this. This is a picture taken by a spacecraft that just was visiting Jupiter on its way to Saturn. But it took some snapshots, as tourists often do, on its way. And look at Jupiter. This is a planet where if you tried to land, you wouldn't. You just sink in and in and in. Jupiter is made mostly of gas and liquid. There is a tiny solid core, but it's mostly a gas and liquid planet. And interestingly, for a planet which is enormous, it's so big that if you put the Earth there, I'll show you Earth in a minute, you could put 11 Earths side by side. 11 Earths side by side into the equator of Jupiter. It's an enormous world, and yet despite the fact that it's so big, it spins on its axis in very, very short time, about 10 hours, basically. So here's this huge cauldron of gas and liquid whipping around in only about 10 hours. So what are you going to get? The technical term is sloshing. You're going to get a lot of sloshing. And here you see these sloshing patterns of Jupiter's atmosphere. So what we have is a world in which the turning of the planet, the rapid turning, the up and down circulation in the atmosphere, there's a lot of hot material rising and colder material going down, it creates enormous storms. So what you're seeing here is weather in the atmosphere of Jupiter, and I think everybody recognizes that there's one particularly spectacular storm. Where is it?
Yeah.
Right there below the equator to the right. We call that the Great Red Spot because it's a little redder. We've taken excellent close-up pictures of it. Here the color's been exaggerated slightly, but it's not bad. Ladies and gentlemen, a single storm, a single tropical storm, 3 times the size of planet Earth, spinning around in the atmosphere of Jupiter. You wouldn't want to land in the storm, but you definitely want to be looking above the storm and getting a view. Let me show you some of the detailed close-ups that we have. Here also the colors are slightly exaggerated for educational purposes, but we've put the Earth to scale. So just in case you weren't feeling unimportant, this is a good slide to make you feel small. Even some of these curlicue storms, can you see the wave-like patterns in the atmosphere of Jupiter? Even some of those are bigger than a whole continent. So this is weather unlike anything the 11 o'clock news team dreams of. It's really quite dramatic storm systems, and we're actually learning a little bit about weather on Earth by studying the really dramatic weather on Jupiter. But the Great Red Spot is definitely one of my favorite tourist destinations. Now, interestingly, Jupiter has 4 moons, which are really worlds of their own. If these moons didn't have the bad luck to orbit Jupiter, we would call them planets, and we would make kids memorize their names in 5th grade. But because they happen to form around Jupiter, we just call them moons, and they don't get the same press that the big planets get. But here are the 4 giant moons of Jupiter, discovered by Galileo more than 400 years ago now. Each one of these is a unique world with something strange going on. The top one is called Io, the next one is Europa, then Ganymede on the right, and Callisto at the bottom. Each of these is a world of the size of a small planet, and each of them has unique characteristics. So here is Io. Take a look at this. Now, wouldn't you agree that no self-respecting moon should look like this? Look at it. I mean, some of the people call it the pizza moon, but if Domino's delivered this, would you accept it? Doesn't it look like it's got mold on it or something? When the pictures first came in, Carl Sagan, the great astronomy explainer, said, this looks like it desperately needs a shot of penicillin. Right? I mean, it's just really disgusting looking, but when we saw it, we were amazed that a moon orbiting Jupiter would have this kind of appearance. Notice it doesn't have any of the characteristics that you associate with moons. Typically, moons like our own moon have craters, giant holes made by big rocks that hit. You don't see a single crater on this picture. Typically, moons are pretty boring colors. They're grays or browns. They have the look of rocks. Nothing like that. You see these lurid reds and yellows and oranges and whites. It looks a lot like snow, especially if you've spilled some horrible chemicals into the snow. And everyone was just amazed, didn't know what was going on. By the way, do I have a pointer here? Is there a pointer somewhere? Or I can point with my fingers. But what I want you to notice is in the middle, going to the right, you see something like a hole with a ring around it, and there's a snake coming out of the hole. Can you see that? Can you see, if you go right to the middle of the picture, then go to the right, you see a ring, which is kind of whitish, and then there's an X and a hole, and there looks like what's a snake coming out of that hole. Well, that snake is actually a plume of material. And what we've discovered is that the reason Io looks so weird is that it is the most volcanically active body in the solar system. It's in a constant state of eruption. Every time we have a spacecraft going by, we see some set of volcanoes going off, not always the same volcanoes going off, and we now understand a lot more about it. Little Io is caught between the the gravity of giant Jupiter and these big moons on the other side, and the mutual gravity of these worlds is massaging the insides of Io. Massaging and massaging and massaging. It's sort of like an airplane passenger on a really bumpy ride. Have you ever had this experience? Your insides are dying to come out, and there aren't enough holes through which to come out. I don't want to get too disgusting. Well, that's how it is on Io. Io is being massaged inside by the mutual gravity of these different worlds, and the result of all this massaging is that the insides are dying to come out, and because the crust is relatively weak, there are plenty of places for the material to emerge, to come out of Io, and so we see dramatic volcanic activity. And so I'd like to show you my favorite tourist site on Io. This is a, thank you so much, instant service. There we go. So this is a volcanic plume called Pele, named not after the soccer player, but after the fire god. All the volcanoes on Io are named after fire gods. And can you see the hoofprint-shaped mound? Here's the hole. And ladies and gentlemen, silhouetted against the blackness of space, shining with reflected sunlight, you see an enormous plume 180 miles high. Take that, old faithful. 180-mile high plume of material which has been let go, which has been blown out of this volcanic cavity. And it is only one of many such volcanoes going off at any time on Io. It's the most volcanically active world. You wouldn't want to go anywhere near there unless you're well protected. All the material coming from these volcanoes comes out at pretty high speed. It actually makes a ring around Jupiter where Io is. But if you're well protected and if you're a rich tourist, you might want to swoop through one of those volcanic clouds just to say you've done the volcanoes on Io. All right. Yeah, there are actually, if you were to take a more detailed study, I also want to mention Europa, the second moon of Jupiter's, which is the most icy body, the most smooth icy body we know. And we think under the ice there might actually be a liquid ocean, but that's a topic for another day. That's something the teachers can pursue on their own. I want to move you on to my favorite planet and everybody's favorite eye candy in the solar system, the ring planet Saturn. Now, here the colors have been exaggerated. Saturn is actually quite smoggy, so if you take a regular picture of Saturn, you can't see this band structure. It just looks like Los Angeles on a bad day. You can't see anything. But it is a beautiful planet, and like Jupiter, it's made mostly of gas and liquid. In fact, Saturn is made of such light gases and liquids that on average, it's lighter than water. The whole planet is less dense than water. That means if you had a bathtub big enough, Saturn would float. Of course, imagine the ring it would leave. Ooh, I get to make that once every lecture. Sorry. But indeed, Saturn is a less dense planet than water would be, and so it is an amazing world. You can't land on it, but you could perhaps land in it. But what we're interested in is the ring. 4 of the planets in the solar system have rings, but Saturn's ring is by far the most dramatic one. So if you're going to send tourists anywhere, you want to send them to Saturn. That's where the spectacular ring system is. Here you see the rings of Saturn because the sunshine is reflecting off them, just like it's reflecting off Saturn, and you see the full extent of it. And from far away, it might almost be that the rings are a skating ring, right? You can imagine that this is some kind of ring of ice glowing in the sunlight, and you could go skating on it, but don't try it. In fact, the rings of Saturn are made up of billions and billions of individual chunks of ice. It's as if there were billions of icy moons all going around Saturn, and they're in a traffic pattern which makes a ring-looking thing from far away. Close up, this would be many, many individual moons. Yeah, this is not a photograph. I'm cheating. Nobody's been dumb enough to actually put a spacecraft into the rings. But this is an artist's impression, actually by an astronomical artist, William Hartmann. So this is an accurate astronomical representation of what it might be like if you were in the rings of Saturn. And what we're seeing is many, many, many pieces ranging in size from about the size of a grain of dust all the way up to about the size of a camper, of a big recreational vehicle. That's the range of sizes that we've measured. How do we know how big the particles are in the rings of Saturn? We've never sent a graduate student there with a tape measure. How do we know the size of them? Well, this is fantastic. We've actually been able to bounce a radar beam from Earth off the rings of Saturn. Talk about a remarkable experiment. A radar dish, a radar antenna on Earth, has sent radar beams, which are like radio waves, to Saturn. Some of those radar waves have bounced off the particles in the ring, and they've come all the way back to Earth from Saturn and allowed us to measure how big the ice particles are in the rings. Remarkable achievement. So we can't use the entire ring as a tourist attraction because that's forbidden by the rules of the game. It's bigger than the whole world, so that's not okay. But I have a particular ring in mind. If you look carefully outside the main ring of Saturn, and by the way, can you see that here in the ring gap is actually a little moon? There's amazing things you can see on these pictures. These pictures that I'm showing you from Saturn, by the way, were taken by the Cassini spacecraft, which is still in orbit today around Saturn, and sending back remarkable pictures of Saturn, its rings, and its moon. So here we see the tourist attraction I'm interested in. Outside the edge of the main rings, which is very sharp and clean, there is a tiny ring, a separate structure all by itself, which is much thinner than any of the other structures in the rings. It's called the F ring. It's called F because the rings were named in order of discovery. A, B, C, D, E, F. No bad connotation with naming the F. But this is a thin, separate ring, and already you can see that it's kind of braided and it's got structure in it, and it's quite thin. And we were quite confused why a ring of chunks of ice, where outside the main ring structure, would stay together. Why would they get pulled into Saturn or drift apart over the many billions of years that this ring structure may have been around? And now we know why. Can you see this? This is called a shepherd moon. And we've discovered 2 shepherd moons near the F ring of Saturn. These shepherd moons act like sheepdogs in a herd of sheep. Now, I don't know how many of you have done any shepherding. Anybody? A professional shepherd in the audience? No, I didn't think so. So let me remind you what shepherds do. When you're a professional shepherd, your job is to keep the flock of sheep together. If the sheep drift off and get run over or fall off a cliff, you're in bad trouble. So a shepherd dog is used to keep the flock together, and a shepherd moon does the same thing. Imagine we have a flock of ice pieces, and the role that these shepherd moons, one on the inside, one on the outside, play is to keep those chunks of ice together in the F ring and not let them drift apart. And when we first saw this, we were amazed that such a thing exists, but now we have much better pictures. Here's a picture from a spacecraft coming in to look at. Here's the outer shepherd moon, and you can see there are many strands in the F ring. But physicists have since then worked out the mathematics of how 2 shepherd moons, one on the inside, one on the outside, can keep this ring system together. So I recommend the F ring of Saturn as one of your main tourist sites, if only because the couple have just exchanged rings. So it's very romantic that they should go see the ring. All right, moving quickly along. Now there are many, many moons around Saturn. I should have told you that Jupiter has 63 known moons, and Saturn has 60 known moons. If you're a teacher, please don't make the kids memorize all those moons. That's a very bad form. But among the 60 moons, most of them pathetic and small, that Saturn has, this is now the moon of second greatest interest, or perhaps greatest interest. This is a completely nondescript, medium-sized moon called Enceladus. For a long time, Enceladus was just a name for us. We didn't have good close-up pictures of it. But now we have these remarkable pictures. Notice that the Enceladus, if you look carefully, has a split personality. There's this side, which is cratered and quite different from this side, where you see almost no craters at all, and you see these long stripes. You see the long stripes? Very interesting. Why is half the moon different from the other? And what's happening with these long stripes? So here, just to show you how unimpressive the moon is the same picture compared to Great Britain. Right? Now, Great Britain's not that big. This is not an especially impressive moon. This is not a moon the size of a planet. The actual size, I'll give you how big it is only 310 miles across. Right? That's not that impressive. So we expect tiny moons like this to be extremely well-behaved and sort of sit there and mind their own business, but that's not what's happening here. Let me show you one of the most amazing pictures that have come back ever from planetary exploration with robot spacecraft. Here's Enceladus in the dark. And you often find people doing things in the dark that they don't do in daylight. And same thing here. You can see that the planet, that the little moon, is actually giving off geysers. These geysers are like eruptions from the surface, like Old Faithful. We call this Cold Faithful rather than Old Faithful because it's a distant part of the solar system. And what we're getting here is salt water. Literally salt water. The saltiness was just announced a couple of weeks ago, actually. They measured that it was water, but now we know that it's actually salt water coming out of here, which may well mean that there's a saltwater ocean under the ice of this little moon. Let me go back. And under the icy surface, there may be an ocean of water, and where the eruptions are coming from are these bluish stripes. They call them the tiger stripes of Enceladus. And the eruptions may be coming out of these bluish stripes. So, this was a world that nobody knew about or cared about. It's probably not in most textbooks, not yet, because it was not considered that important. But suddenly everybody's paying attention to Enceladus. It sounds like enchilada, but it's Enceladus. All right. And almost at the end, I want to introduce you to this one. This is a moon of the planet Uranus that, again, probably hasn't gotten much press. It's called Miranda. Anybody here a Miranda fan? No, I bet a couple of people are Miranda fans, but most of the public has never heard of it, but I like it a lot. First of all, look at it. Again, no self-respecting moon should look like it. Look, for example, at the California lottery symbol. You see that? Right there? What's it doing there? Right? And look at how kind of square or rectangular this region is. Then over here, there's a racetrack. You see the racetrack over here? Here, there's smooth area. Here, there's actually another racetrack up here. And then there's this cratered area over here. And then something weird happened over here. So what's going on? This looks like the kind of planet your little brother would build. right? Not that well made, I'm too tired to do a good job, what the heck, let's just put it together. It's not a decently assembled world. We think that there's been some cracking, there's maybe something in it, and it broke apart and then reformed. Nobody quite knows why this world has so many different separate regions, why it looks so strange, but I want to focus right here. This is one of the most interesting places in the solar system, and there's a close-up. Ladies and gentlemen, welcome to one of the tallest and most intriguing cliffs in the entire solar system. Here the world, Miranda, has separated. And as it's separated, there is an enormous cliff face that has gotten exposed. It goes even deeper than we can see here. And this cliff is actually 12 miles high. But this is a tiny world. Miranda is not that big a place, so the gravity is actually really quite low. The size of this world is not that different from Enceladus. It's about 300 miles across. And so the gravity is 0.8% Earth gravity. What does that mean? That means a 200-pound man would weigh 1.6 pounds on Miranda. So Jenny Craig likes this a lot. A 200-pound man on Earth would weigh 1.6 pounds on Miranda. So if gravity's so low, and you and your sweetheart have a fight, and you decide this relationship isn't going to work out, and you're going to leap off that cliff, you're not going to fall that fast. Because gravity is only 0.8% of Earth. So if you took, pardon the expression, a lover's leap off the face of the Verona Cliffs, these are called the Verona Cliffs. What's Verona? Anybody know what place Verona is?
Romeo and Juliet.
Oh, it's a place in Italy where the play Romeo and Juliet took place. And how did Romeo and Juliet end for the lovers? Not so good, right? So we've named the biggest lover's leap in the solar system the Verona Cliffs. And I'm here to tell you that if you were jumping off the Verona Cliffs, we've calculated you would have 12 minutes from the time you leaped to the time you landed. That's a long time to regret your decision, to apologize to your sweetheart, and to make things up. And then when you landed, actually airbags could save you. If you just happen to be wearing airbags, which I'm sure many tourists will in the future for safety, then you could probably expand your airbags and survive the fall off the Verona Cliffs. So this is perhaps not the most romantic of places unless you want to end things, but well worth looking at as a fun adventure. Even if you don't want to leap off, the view is remarkable. The Verona Cliffs on Uranus's moon, Miranda. And finally, we want to return to Earth. We look at Earth here on this picture, and we see that there's been no world that I've shown you that's anything like planet Earth. Planet Earth is surrounded by an atmosphere that we can actually breathe. It's surrounded, it's got a surface which is 2/3 water, which we like to drink, right? And so this is a world where we can actually survive without a spacesuit. That's not true for the other worlds in our solar system. Even our closest neighbor, the moon, is a place where you can only survive if you're wearing a spacesuit. We found that out because 12 people have landed on the moon. We've explored the moon, we've ridden dune buggies on the moon, we played golf on the moon, we've left American flags on the moon, despite what the crazies say, who say we've never landed there. We actually have done all those things, and here you see footprints on the moon. Human footprints on the moon, and I'd like to suggest that as my last tourist site. Because the moon has no air, it has no weather, no atmosphere, no life, not even on Saturday nights. Because there's nothing that changes the surface of the moon. Both the picnic garbage we leave there and the footprints we make in the lunar soil will remain untouched for millions of years. So someday Disney could come, put a fence around it, and start charging admission. Come see the very first human footprints on the moon. But I suspect we will go back and visit that very first place where a human being stepped out and made a footprint somewhere else besides the Earth. Well, that's my tour. And what I hope you'll take away from this is two things. One, that there are a lot of interesting places to visit in the solar system. That as we've started to explore this amazing retinue of worlds which accompanies us around the sun, we found lots of interesting sites to visit. We're just starting to get to know the surfaces and the various moons and rings of these worlds. And there's so much that we're going to learn, so much that we have to explore. If you get sick of exploration on Earth, there are many other places to go. At the same time, I hope you also saw that these are alien worlds. There's not a single place where we can land and just take a breath, or where we wouldn't freeze or burn to death. So if we mess up the Earth, if we do something to our own planet, by God, there's no other place where we can easily go. We'd have to do enormous engineering to be able to live on any of these other worlds. So the other conclusion I hope you will take away from this is what Dorothy said at the end of The Wizard of Oz. There's no place like home. Thank you very much. Let's bring the lights up. Do we have time for questions, Alan? Or what's everyone saying? Okay. I'm told we have a couple of minutes where I'm happy to answer questions if people have questions or embarrassing jokes they want to tell. And then the teachers will go back to the room and I'll join you here. So if there are teacher questions, we can deal with them there. Great. So.
Man exploration or exploration?
Yes. The question is, which do I prefer? Human exploration or robots? And I think there's room for both. NASA paid me to say that. But you know, I think it's a question of resources. If our resources are limited, I hope this tour has shown you how much robots can do. Our robot representatives are really good because they don't need to eat, they don't need to breathe, they can use solar energy like the little rovers on Mars, which are tooling around on Mars. So there's an enormous amount that we can learn from robots. On the other hand, there's nothing more exciting than a human being actually exploring. So in terms of the politics of it, the sexiness of it, there's very little to compare with human exploration. So if there's a lot of resources, I think we should do both. If we're limited, the robots per discovery are a lot cheaper. Other questions? Tourist sites that I didn't cover.
What do we know of the, not the construction, but the composition of the moons of Jupiter?
What do we know about the composition of the moons of Jupiter? Well, that's a non-trivial question. One of the things that we've learned about the solar system, all the planets, is that as you go away from the sun, the composition of the planets changes. So near the sun, the planets are mostly solid and heavy. Mercury is a slack heap of metal. Because it's so close to the sun, it couldn't stand the heat. All the light material that could have been part of Mercury evaporated away, being so much in the hot part of the solar system. The further away you get from the sun, the more lighter materials were able to stick around and not jiggle away. That's the technical term, jiggle away, evaporate. And so the outer planets are lighter, the inner planets are heavier. Interestingly, the moons of Jupiter have the same pattern. The original Jupiter mass that formed must have been hot. So more heavy material inwards, more lighter and icy material outwards. But there are many, many different kinds of materials in each of the worlds, dominated by water ice out there. We think that Europa, the second moon, for example, has an icy cover made mostly of water ice with liquid water underneath. We know that Io, on the other hand, has quite a bit of other materials. It's got sulfur, because we know some of the volcanoes have sulfur. So there's a rich sort of aggregation, or a rich variety of materials that the different moons are. Other questions, thoughts? Lunch is overdue. Yes?
Well, speaking of lunch, the image of Io, the pizza plant, pizza moon, seemed to have a kind of a flat edge on the right side. I don't know if you noticed that. Said maybe the pizza box got shuffled in the window or something.
That may, oh wait.
I'm wondering if that was an artifact of the imaging system.
Yeah, I'm sure that was. It's a round world, but let's take a look at what you mean. And we'll go quickly to Io. Like there? Oh yeah, that just got cut off because this is actually a mosaic of images which look like they're one, but there's actually many images put together in early versions of Photoshop, as it turns out. And so just the edge got cut off. And it's definitely a round board. Good eye. Very good. Yes, sir.
So on the shepherd moons, going around the rings, when you look at the rings, it looks like the rings are being distorted.
Yes.
Is that because of gravitational
That's
pull on
right.
the shepherd moons?
Very good. Another person with a good eye.
Like right
So
Yes.
right there, you can see that the shepherd moons make the F ring kinky. There are too many kids in the room for me to pick up on that. But as long as you talk about honeymoon couples, these are kinky rings. Okay? That's what we call it. But absolutely, it's as the shepherd moons go by, the moons orbit at a slightly different rate than the ring particles. So when they come nearby, they distort. The gravity actually distorts the pattern of the ring particles, and that's why you get that kinkiness. At first we thought it was braided, but actually it's more distorted by the presence of the shepherd moons, exactly as you said. Yes, sir?
How do we know what we're looking at when we see these images? So, you know, think of like the river of what's inferred to be lava, or the expulsions of salt water, or what's on Io, for example.
This
There's really
is
compelling pictures, but like I feel like I could make hypotheses, multiple hypotheses about what things are.
This is excellent. This is just the question I encourage my students to ask. What I always like, and you're so polite, you would never ask this, but what I always ask my students to ask me is, why should I believe a word of this? If only we said this more in our political discourse, we would be so much better off. Why should I believe a word of this? And you put it so eloquently, it's absolutely correct. We can't just from the pictures tell that it's salt. No, all we can see is that there's an eruption. We can, from looking at the picture of Io, tell that there's sulfur in the volcanoes. So these robot probes that we send have many other instruments besides cameras. But the press generally only covers the pictures. And in introductory talks, of course, because they're beautiful, we emphasize the pictures. But just to give you a specific example, so in the case of the Enceladus geysers, we actually programmed the spacecraft to come so close to this moon that it went through the evaporated salt water. And there are actually instruments for measuring the composition of particles, of individual atomic-sized particles and dust on the spacecraft. So as we sent the spacecraft through the plume, we actually got back information about what it was made of. But we couldn't have told that from the pictures. We need to have specialized instruments measuring composition, measuring the kind of light that's reflected. Often the colors of light that are reflected from an object tell us what the object is made of, because different elements reflect and absorb light differently. And an enormous amount of time and thought goes into what instruments we can put on each robot probe so we can actually answer questions like this, and I can give funny talks. Yeah?
How many probes did it take to get this many wonderful pictures? Is this the result
That's a great question. I haven't counted up how many different probes I've used in my pictures, but if I can answer your question more generally, dozens of probes have explored. In order for us to get to learn what Venus was like, first we sent something in orbit around Venus, and it was very frustrating because we couldn't see anything. Then we said, all right, let's send things into Venus. Then let's land things on Venus. Then let's do radar probe. Say it again?
First it was a flyby.
First it was just a flyby, that's right. So it took many different experiments before each planet gave up its secrets. But ultimately, what we want to do is to be able to measure, not just take pictures, but as I said in my previous question and answer, to measure the characteristic of each world. Sometimes only from space, but sometimes by landing. We've landed on a number of worlds, and that's of course really good. But it's taken dozens of really advanced robot probes to give us this picture, and of course there's a lot more to the picture than I was able to show you in 15 minutes. Keep going.
So this is pure science, I think. We don't claim this as a practical use in an era of limited resources. It's like we got Velcro from going to the moon.
Yeah, I think we could have gotten Velcro a lot cheaper than going to the moon, right? That's not the reason we went to the moon.
What is this, aside from the pure science and in the fullness of time, we'll be glad we did this.
Yeah, what's the reason that we as a society should spend money on this, is what you're asking. And there are so many ways of answering that question, and I'm sure we don't have time for all of them, so let me just touch on it, because I know we have to get out of the room. But let me touch on some of my favorites. First of all, it's not quite true that there's no practical value. For example, we've learned a lot about global warming by studying Venus, where global warming has run amok. We've actually learned something about weather by studying the weather on Jupiter. But that's the same argument as Velcro on the moon, right? There's much cheaper ways to study the weather than to go all the way to Jupiter. So the two reasons that I like to particularly talk about, one is simply exploration. Right? We are one planet among many. Some of you may have heard that we've now discovered 500 planets for sure, and maybe thousands of planets around other stars. Tomorrow night we're going to have a free public panel with the planet discoverers that are using the Kepler telescope to actually show us an incredible wealth of new worlds. So we are just one planet among maybe thousands or billions of others, and it's like knowing about only one country, or knowing only about one animal. If that's all you care about, is your own country or your own animal, that's fine. But you're not really educated until you learn about other countries and other animals and so on. The other reason is because, if I may say, it's sexy. When you've solved all the problems on Earth, is everybody just going to be playing video games and watching really bad television about housewives in different states? Or do you want to give people something more intellectually challenging to think about for the future? Astronomy is a tiny, tiny, tiny portion of the money we spend. It is a tiny part of the budget. But in a way, it makes life worth living, just like great music does and great art does. Because knowing about the fascination of what's out there is part of what keeps me and many other people going when all the daily chores are done. So that would be my answer. So I think that's where we have to end.